I am writing, just you wait. Phytic reaction means that is both the aryl halide. So it
Aryl
will
and
be
alkyl both will be there.
no. Woods phytic reaction means one alkyl, one aryl. Woods means what? One will be alkyl halide, and phytic means aryl. Phytic is
Okay.
given by the what is aryl halide. Woods is given by alkyl halide. Both are the different. But if you are mixing woods phytic, so one will be alkyl, one will be aryl. So these are the conditions are there. Okay, but by the way, you wait. No, I'm writing. Just I'm connecting with other device. Hmm. Yeah, it got connected. No problem. Let me share. So all the three reactions simultaneously I am writing. No.
Sir, that is what I want. Sir, then I can also have the three simultaneously. So sir, in case of any confusion, can refer through them.
Okay, okay, no problem.
Easier
What
to
the see the meaning of woods? If you I will write the woods. Okay. So woods means what? Woods if you are writing now woods. That is what that is alkyl halide.
Mhm.
Woods for which one? For alkyl halide. Take and phytic Fittig. Phytic. This is for aryl halide. Aryl halide.
Sir, if
So
you're writing anything is not visible to me.
it must be visible to you.
No, no, sir, not visible. Not visible. Can check
Now,
once again. Not visible.
now.
Nothing, sir, nothing. I can only see your profile photo. That much only. Nothing more.
Sorry. What is the problem here? Maybe the
Sir, in
Zoom
the
is
morning you were doing with that tablet, so you can do with that only, no, sir. That was better.
no. It is correct only. It must be visible. Can you see anything is visible to you?
No, no, sir, nothing is coming. Not coming.
Hey God. Then what should I do here?
Sir, you can
So
join with that tablet now. That was coming. Everything was right in that one. Sir, your time is going, sir.
now whiteboard is coming. Whiteboard.
No, not coming.
Acha. Then we have to go for that one. Why it is not coming? I don't know. It should come. Actually, when we share the screen, it sometime it does not allow proper to write. That is problem. Now, but I don't have other options.
Now it is coming, sir.
Okay, thank you. So what I was saying that is if I will write you woods, WURTZ, woods, it is for alkyl halide. So no,
Sir, audible.
I don't know what happened here. Something is problem.
I saw, sir, your that we got disconnected.
Uh, see, anything I'm writing, is it visible to you?
I can see woods for alkyl halide. That much I can see.
Uh, Phytic. Phytic. This is for aryl halide. For aryl halide. Aryl halide. And if you both mix, if you have to mix, so that is if you I mix for both woods, phytic, if I will write. So what is that is one we have to woods portion is what alkyl and phytic is for aryl joined together. And in all the cases, what you are doing, you are treating with the sodium metal. In all the cases, we are treating with the sodium metal. Getting? So what is here the three column I am making Woods reaction. Second one phytic reaction. No. Woods phytic. Woods phytic. And last one is phytic. So what will be there if I will write one by one? So Woods reaction, I have to take 2 Rx and treating with the sodium metal. So it give R dash R plus 2 NaX. Woods phytic.
RR plus NaX.
Yes. So here is we are taking this is the X plus 2 Na plus Rx. So what is going to happen? This one will be out. So it is going to give the compound. This one will be R plus 2 NaX is out. Phytic reaction. You have to take 2 molecule of X plus sodium. So what it is going to be? Biphenyl it will give. Plus 2 NaX. Check that whether you are able to or not. So what it is going to be? Biphenyl it will give. Can you understand this?
Okay, understood.
So again I need to explain or that is enough?
Sir, enough only. You told me the reaction, na? That much would be fine.
Okay, then we are going for the another class of reaction, replacement.
Replacement for haloarine. Replacement of haloarine.
Replacement
Sir, you
of.
can ask the question from the Woods reaction, sir. I want to know if I really understood it.
Wait. I will ask you. Let's the finish first one. Okay, some more reactions are there. Then we'll do replacement by the replacement of X. Replacement of X in haloarine by hydroxyl group. By hydroxyl group. Replacement of X in haloarine by hydroxyl group. This we have to understand. Now, although they are saying, although haloarines does not give SN reaction due to presence of partial double bond character. Double bond character. But what they saying? But at high, what the high temperature and pressure, high temperature and pressure, it gets now high temperature and pressure, X gets replaced by OH group. H gets replaced by OH group only. You cannot replace with the Cl, Br, ester, other. We cannot do. Only you can do with the OH group. You can replace by only OH group. Okay, not more than that. Can you understand this?
Sir, understood.
Okay. So total 4 cases are there. Okay. Case 1. Case 1. So case 1 we are doing for in absence of electron withdrawing group, the EWG, in absence of electron withdrawing group. There is no electron withdrawing group in the ring. Then how the reaction will be there? See, this is what is there, Cl is there. So reaction condition is very vigorous. Firstly, you are using the NaOH. Second condition, what you are going to use here? That is the temperature you are going to use. That is 623 Kelvin. And pressure what you are using? 300 atm. And second condition, you have to use the H plus. So here you see the high temperature and pressure is 300 atm, means 300 kg. Then if you are treating now, so what will happen? It is going to replace OH plus it will give NaCl. Side product is not important.
Sir, from where you are getting this H plus that you are adding, sir? Because hydrogen, if you talk about normally, it will be in the form H2, no?
No,
So
it is
that means
actually two-step reaction. It is actually two-step reaction. Rough work. Rough work I am explaining. Rough work. So it is two-step reaction. Here is Cl is there. Now you firstly treat with the NaOH. Na? So it will give, that is what is going to be ONA. And here is what
oh,
will be there.
got it,
HCl
got
is
it.
out. This is called sodium phenoxide. Sodium phenoxide.
Phenoxide.
But it is not very important. So that is what is then. Here is already acid is there. Na? H plus it will be. So suppose you HCl you are saying, so now it will come NaCl. And this will give what? That is the OH. So it is the, but these steps are not required. This is the normal reaction now. Done. Done or not?
Doing the last one. This one is called sodium phenoxide.
In case of one electron withdrawing group, one electron withdrawing group. If you are one electron withdrawing group, so what will happen here? I am writing the one step one. Electron withdrawing group, takes the electron, takes the electron, takes the electron of CX bond, CX bond, which makes it, which makes it, which makes it weak, weak, which makes it weak bond. As a result, what is happening? As a result, it gets break. It gets break easily. It gets break easily. It's get break easily with OH group. With OH group, it gives break easily with OH group. So now you see case 2 we are going. Electron withdrawing group, what is there? Here is the, suppose Cl is there, and here is NO2 is there. So NO2 is taking the electron. So this bond is going to be weak. This become the weak now. So it will be easily going to be replaced. So here the reaction condition will be less vigorous. NaOH 443 Kelvin, pressure not required. And second one you have to do H plus. So easily it is going to replace. Here it will be the OH and here is going to be NO2. Getting?
Yes.
Hmm.
Done.
In case of two electron withdrawing group, so what will happen? two EWG group makes CX bond much weak, makes CX bond much weak, which easily gets break. So now you see, if the two electron withdrawing group is there, Cl, this is NO2, here is again NO2. So reaction condition, you see, what are there? This is NaOH, 368 Kelvin, temperature reduced. At second one is H plus you are taking. So what it will going to give? Here is this is OH, here is NO2, and this is NO2. So as many electron withdrawing group are there, what they are going to do?
Sir, they are gradually weakening the bond actually. So that is
They are going to decrease the strength of CX bond. Case 4. In case of 3 electron withdrawing group. In this case, what the point is, in this case, the CX bond is weakest. The CX bond in haloarine are weakest. So no need to heat during the reaction. Heat is not required during the reaction. So what we are going to do here, you see, here is the Cl is there, this is the NO2, here is going to be NO2, this is again going to be NO2. Here you are taking H2O, and it is the warm H2O. You are taking the warm H2O, and it will give this compound. This is called the 2,4-trinitrophenol. This is NO2. This is NO2. This is NO2. This is the TNT. TNT means 2,4. Trinitrophenol. TNP. 2,4,6 trinitrophenol.
what is that one? Trinitrotoluene formula is sir?
That is OH will be there will be CH3. At the place of OH, there will be CH3.
Sir, that is the material for making the bombs, no?
Yes. This is a strong acid.
Done.
All done.
Done.
Now we have to do some problem. 1 second. Na? This is also called Sanoe, picric acid, strong acid. Na? This is called picric acid, PICRIC, picric acid, that you need to keep. Sometimes they ask the formula picric acid. So 2,4,6 trinitrophenol is also called picric acid.
Mentioned in the NCERT.
I don't know, it is not given or given. And this is the explosive.
TNP is also explosive.
TNT is also explosive. This is also explosive. Getting my point?
Yes.
Okay. Actually, it is taken from the Greek word pikroch, and that is for picric acid. Now, let us move out and how electron withdrawing group increases the replacement replacement reaction rate. Okay, explain. They
Sir,
are
for
saying that.
replacement reaction means that the bonds need to be broken. CX bond needs to be broken. So, sir, if we have increasing number of electron withdrawing group, sir, we have already seen before that when the number of electron withdrawing group increase, then the stability or strength of the CX bond decreases. So, if the electron withdrawing group is present in more numbers, then the
Mhm.
strength of CX bond will decrease, and subsequently the replacement reaction will require less energy, hence the replacement reaction rate will be increased.
That is correct only. See here. Here is what we are having Cl. Here is the bond are there, suppose. This is the N double bond O, and here is the coordinate bond O, right? So what is happening here, if you make the attack of OH minus ion, so once if it is attack here, na, in this position it has to attack. So this bond has to split out. So now you see what is happening here. Now it is the electron is withdrawing. This is electron is coming here. This group is pulling the electron. So what will be happen? In this case, you see the one will be the Cl here, another will be OH here. This is the negative charge. Here is the bond. This is the N. Here is the O, and this is coordinate bond O. Now so what you are going to find in this case, this one is going to involve in the resonance, negative charge. This is going to involve in the resonance. Suppose this is coming this place, so if it will come this place, so negative charge, this bond will come out to this place. So another structure you see, just I want to show you the single bond and nothing else. So negative charge come here, this become the bond. Here is N double bond O or coordinate bond O, and this is the one place. Here is what is there. One side it will be the Cl, another side will be OH. This is OH. Now this bond is going to shift this way, and this is coming out like that. So what will be the another one? This one is the negative charge. Here is the Cl. This is the OH. This is there. Here is the N double bond O coordinate bond. This is now what will happen? This is the like that. This is the bond. Now if you make the resonance hybrid, actually structure is called resonance hybrid. So what you are going to get here? You will find the pure single bond you will find. So here is this is the N double bond O coordinate bond O, and here is the Cl, this is OH. And what you are going to find, the negative charge is not spreading, double bond is not going on the this position. One side where the Cl and OH bond single bonds are there, that side it is not, it is the pure step. And here is this is the slowly it is going now. Here is very fast. What will happen? This is completely Cl will be out. This part is little bit difficult to understand. Here will be NO2, this will be ring plus Cl minus. Quite difficult to understand. This is they will ask, that is how can you express that OH is electron, NO2 is going to withdraw the electron. See, already we understand now SN reaction, or what SN reaction in the single bond. Haloalkane, example of haloalkane. And here whatever the resonating structure you see, the bond, total bond you will find here, this much portion is what? Single bond. Total portion is single bond. So that it can be, why the single bond is coming? Because of the presence of NO2 group. Getting? Hello.
Yes, sir. Audible.
Hmm.
Done.
Okay. The next heading is mechanism of ESR reaction. Mechanism of
Electrophilic substitution.
ESR, electrophilic substitution reaction. Generally, they do not ask, but sometimes they have asked. That is why I am telling you. Mechanism of electrophilic substitution. They have what the point
Around
they are saying. Hmm.
in the
They
middle,
have
sir, not quite. That is why.
what you are saying.
No, sir. In the middle, for some time, I was not able to hear anything. That is why.
Okay. Mechanism of ESR reaction. So how can we write? They are electron rich species. Electron rich species. So they give ESR reaction, which involves following three steps. Following three steps. Step 1, attack of electrophile, formation of electrophile. Formation of electrophile. Formation of electrophile. So suppose any of the reaction you can understand. Suppose I am talking for the Fidelcraft FCA, taking the example, CH3Cl is there, AlCl3 is there. So this Cl is going to be at this place. So it will give the CH3 plus. This already I explained you the 11th standard, AlCl4 minus. This negative charge will be at this side. Because here the 6 electron is there with the aluminum, 6 electron. So here the 2 bond gone here, 2 electron gone here. So CH3 plus, this is what called electrophile. Electrophile. Step 2. What is formation of attack of electrophile? Attack of electrophile. So how you can attack electrophile? Here is the Cl is there. Suppose these are the bonds are there. So better you represent this bond in the different way. Wait. I just want to mention the bond at the different location. So this one. So what will happen? CH3 positive. So it will go here. So now another structure will come. Here is Cl. This is H. Here is CH3. This is positive charge. And this bond are as it is. Step 3. Removal of proton. Removal of proton. Removal of proton. So you can easily remove the proton from this one. Here is the Cl. This is the H. Here is CH3. This is positive charge. And here is the this one proton. Just proton means H plus removing. So this bond is shifting here. See, the mechanism is the supposed to be practiced a lot. Then only you can understand. So this is the reaction. The same way you can do the nitration, same way you have to do the sulfonation, same way you have to do the Friedel-Crafts acylation. All you have to do when you will solve the previous year question, then only you will get to know what type of question asked, whether they ask or not. That also you need to know. Sometime I guess they ask because it is given in the example.
Okay, got it.
This is the all the reaction we have covered. Okay. Now we have
Sir,
to
I'm
study.
writing this one. Sir, you give me little time. Scroll up one shot, sir. You can may also share the screenshot also, sir. That will also be fine.
I will share all the PDFs, that one.
Okay. Sir, I did
Because
not write this one. Then, sir, you please share.
no need to write. I put total is available. This PDF is fully available. Nothing I rearrange. All are there. So I will share you fully. Okay. Next one is there. Stereo chemistry. This is the last heading only. SN1 and SN2 reaction. SN2 reaction. SN1 and SN2 reaction. SN2 reaction. This we are going to discuss. First of all, we have to understand optical activity. Optical activity. Optical activity. See, the optical activity means the compound which rotates, the compound which rotates plane polarized light, polarized light, PPL light, plane polarized light are going to be called, are called what? Are called optically active compound. Optically active compound. They are called optically active compound. And this phenomenon is called what? Is called optical activity. Optical activity. Getting my point?
Yes.
So, what is the optically active compound? Those who rotate the PPL light. Now, the example, what is the PPL light? The light which have polarized vibration. That is above and below the plane. Above and below the plane. Below the plane. Above and below the plane. What do you mean by? Suppose it is the ordinary light. If you see, so I will make you the ordinary light. What is the ordinary light? This is the light. Okay. So ordinary light means they are having vibration in all direction. Ordinary light is having the vibration in all direction. But you pass this light in the prism. This is the what is called Nicole prism. This is what it is. If you talk about, this is called Nicole prism. Nicole prism is the prism which other light, other direction will be scattered out, but only those who will pass in the cavity, the gap in the prism, they will only appear outside. So now you will see this type of radiation only left. Other type of radiation going to be scattered back. So these are this type of now vibration you can see up and down. This is what is called plane polarized light. Now, if this light is the plane polarized light, if this light is rotated by the any compound, that is what is called optically active compound. Now see this one, what we are going to do. This one is we are passing this one. Here you see, this is the compound is there. Okay, I am making the diagram here little bit more. This is the compound. Okay, this compound is there. Little bit you make little smaller because we need to go one more step. Now there is two possibilities are there. This is the optically active compound, OAC, optically active compound. And if this compound rotate the PL light in clockwise direction, if it is rotating the clockwise, you must have heard this one. If you rotate the clockwise direction, this one, this direction, that is called deform OI, OA, optically active compound. Deform optically active compound. And if it rotate left form, this side, left direction. So what is this is rotating this side. So this is called L form optically active compound. Optically active compound. This is also called dextrorotatory. The name is dextrorotatory. Dextrorotatory. And this is levorotatory. Laevo. Levorotatory. It means if I will ask you the optically active compound. So optically active compound means rotate plane polarized light. Rotate, what is? Rotate PPL light. PPL light. PPL. They are two types. One is called D form O optically active compound. D form optically active compound. Another is L form optically active compound. If it is rotating right direction, rotate PPL. You rotating PPL right direction. If it is rotating right direction, okay. So if it is rotating right direction, rotate PPL right direction. So that is called dextrorotatory. Dextrorotatory. And if it is the rotate left direction, rotate left direction. Left direction. So if it is rotating left direction, what is called? Levorotatory. Laevo. Levorotatory. Okay. So dextro means this one with the rotation will be clockwise. You must be understanding. I hope. Are you getting this?
Dextro means right side and levo means left side.
What is the optically active compound then? Optically active compound definition. Those compound which rotate the PPL light. That is what is called optically active compound. And those which rotate the left direction, that is what is called the right direction, dextrorotatory. Left direction, levorotatory. And this is the dextrorotatory. It is represented by positive. And levorotatory also represented by negative. Positive sign you can represent and negative sign represent. Clockwise means positive sign. Anti-clockwise means negative sign. Done.
1 second. Almost done.
Today you finish this chapter, right?
So
It
how
will
much
take
more time?
another 20 minutes.
Okay. I can do. Not an- Done.
Okay. Now the next heading is there. Condition for optically active compound. Condition for optically active compound. Optically active compound. Condition for optically active compound. What are the conditions? First one. Compound must not have symmetry. Compound must not have symmetry. That is asymmetric compound. SYMMET. Asymmetric compound. Compound must not have symmetry. This is the first point. Second one. What will be the second one? Compound must be chiral. Compound must be chiral. That is, carbon must join with four different group. 4 different group. Are you getting this?
Getting.
Okay. These two are the most important point. Now, what we are going to go do, that is enantiomer, ENANTIOMERS, enantiomers. Two or more than two compound, which a third point also there. They must not be, third point also there, they must not be superimposable on their mirror image, they must not be superimposable on their mirror image. This is the what point. Okay, three conditions are there. We are writing the enantiomer. What is the enantiomer? Two or more than two compounds which are non-superimposable. Two or more than two compounds which are non-superimposable. Wait, Sanana, let me find out the definition here. This one. Let me change the definition. I am writing for the NCRT, although it can be defined in the. They are saying two or more than two optically active compound, compounds which are superimposable means that must not cover, non-superimposable on their mirror image, is called enantiomer. This is given in the NCRT. ENANTIOMERS are called enantiomer. So enantiomer are what they are the what we can say, they are the optically active compound, but they are non-superimposable on their mirror image. That is what called enantiomer. Now, another heading is there, racemic mixture. What is the racemic mixture? If you talk about racemic mixture, 50% D form, optically active compound, plus 50% L form, optically active compound. Both are together is called racemic mixture. Okay.
So what is the full form of OAC? Optically active compound.
And racemic mixture, this one will rotate the clockwise. This will be clockwise rotating, right? And another is rotating the anti-clockwise. So what they will do, they will cancel out their rotation. They will cancel. So they are optically inactive. Optically inactive. They are optically inactive. Where it is found? Found in SN1 reaction. SN1 reaction. found in SN1 reaction. Getting?
Yes.
Ab now the stereo adding stereochemistry of SN1 reaction. SN1 reaction. SN1 reaction. We are writing stereochemistry of SN1 reaction. Stereochemistry of SN1 reaction. So what is happening? Step 1, if you take step 1, formation of what? Carbocation. In the step 1, formation of carbocation takes place. So what will happen? Suppose this is the 3 degree. Here is CH3, this is CH3, this is CH3, this is X. So what will happen? Carbon, it will give the, now it become the sp3 hybridized. This is the planar structure because only 3 bond is there na. So it is the sp3. Here it was the sp4, sp3, but it become the sp2. Here tetrahedral, it is this. Now step 2. It gives racemic mixture. How it will give racemic mixture, you see. Okay. So step 2, what the possibilities there? Equal possibilities there that it can attack on the either side. Positive charge is there. If it is attacking from this side, OH minus, and it can attack from this side, OH minus. It can. If it is attacking this side, so other compound will form. If it is attacking this side, so other compound is going to form. So let us see. If it is attacking this side, this is called OH this side. Then see, here is CH3, this is CH3, this is CH3, right? And if it is attacking from this side, so it will be there CH3, this is CH3, this is CH3, and here is OH. So these are the structure. Now this one is rotating this side, and this one is rotating this side. So both, if it is the D form, okay, and it is what is there, L form, and this is equally how much percent? 50% this one, 50% this one. So in the solution, what will be there? This is going to form the racemic mixture. So SN1 reaction form the racemic mixture, that we have to understand. How SN1 form the racemic mixture? In the step number 2, when the carbocation form, which is sp2 hybridized planar structure is there, it can attack from either side. So if it is attacking from the either side, so what will happen in this case? That is, one will be D form, another will be L form. Not understanding?
No, sir, understanding. But I am writing this one, sir, this composition of this one, racemic mixture.
Okay. That you can write, no problem. Can I erase?
Yes.
Hmm. Here they are saying the explanation of question there. Explain retention, comma inversion in what the compound they are saying 2 methyl butane 1 all in 2 methyl butane 1 all 2 methyl butane 1 all. Otherwise you wait son, let me change the question. Explain retention inversion comma inversion comma racemic racemic mixture in compound. Which compound they are talking about in compound? Here they have given the compound. Stereochemistry 3D structure they have given. This structure is C2H5. It will be difficult to you to understand at a time, but I will explain you tomorrow also, so it will be 100% clear. There is
Okay.
no need to worry. Tomorrow again I will explain. This is the compound is there, and they are saying now what you are going to do, Sanoy. This one, so I am writing the solution. First of all, retention. Retention means the incoming group takes the position of living group. Takes the position of living group. Position of living group. Position of living group. This is what is called retention. What is inversion? Inversion means what is coming group. Incoming group. They are saying incoming group takes the position of incoming group takes the position of position opposite to living group opposite to living group opposite to living group. Racemic mixture, that is you already know. Mixture racemic mixture means 50% D form plus 50% L form. Now, so the compound I am taking again I am making the diagram of the same compound. You see this one, C2H5, C, here the hydrogen are there, this side the hydrogen, this is the bond representing away from the carbon observer, this is X, and this is the now this compound is optically active compound. Why? This is the chiral. Why the chiral? Because 4 different group are there. Now you replace with the Y. Okay, you are replacing with the Y. So what will happen if you are replacing for this one? So the compound going to form, how the going to compound is going to form, that we have to observe closely. So this one C2H5, here it comes Y, this one is the going to be H, and this is the going to be what is there, going to be CH3. So this compound is identical to this compound. The living group you can see, this is the living group, X is living group and this is incoming group taking the same position. So this compound is, can you tell me, retention or inversion? Can you tell me what it will be there?
So this will be retention.
Thank you. This is the retention. And here you see hydrogen is there. The other side, this is the Y, this side came, and this one is this one, CH3. So all disarranged. So can you tell me what this compound is? You can see the position of X is here, living group. and incoming group is opposite to the leaving group. So this is the inversion. This is inversion. Are you getting this?
Getting it.
So this is, if I will call this retention is, if I will consider to be D form, if I will consider D form, and this one I am considering to be L form. So both the mixture, D form, both the mixture in the solution, D form, L form, this is what going to form? Racemic mixture. 50% retention and 50% inversion. That is going to be racemic mixture.
Understand.
Okay. Now the last point I am explaining today, then I will wind up this one. Stereochemistry of SN1 reaction. SN1 reaction. This is the last heading of this one, SN1 reaction. Then tomorrow we have to do the problem on it, SN1 reaction. So now, in this case, attack is from opposite side, opposite side. So the inversion of configuration takes place. Inversion of configuration takes place. Called Walden inversion. Called Walden, Walden, Walden inversion. See the point here. This is the H. Here is C. This is H. Here is H. SN2 reaction always takes place in 1 degree alkyl halide. And here is the OH minus. If you attack this one here, so what will going to happen here? This is the OH is going to form this one carbon. Here is X is going to be out. This is hydrogen. This is hydrogen. This is hydrogen. Now you see this structure. This is the opposite to umbrella. If I will do, this is umbrella. Why it is opposite? Because the stick is out upward. If the stick is like that, this one is the structure. Stick is like that. This is the proper umbrella. But now the stick is here. This line is the opposite. So that is called inversion. Walden inversion. Now this one you see it was the slow and last one is fast. Which side OH group is attacking? Can you tell me which side OH group is attacking? It is the retention or the inversion? Can you tell me? This is the leaving group and this is incoming group. So this is the inversion or retention?
This is inversion.
Inversion. So that is in SN1 reaction. What is takes place? SN1 reaction, that is racemic mixture. That is inversion and retention both takes place in SN1. But if you talk about SN2, here, oh, this is SN2, na SN2. Sorry. In the attack is from the opposite side, inversion. SN2 reaction means what is? Inversion only inversion. But SN1 reaction, that is the 50% inversion, 50% retention. That is the racemic mixture. So tomorrow we are going to solve the problem based on it.
Okay.
You know, you don't need to study this one. If you can read 1-2 times, that is okay. Tomorrow we will discuss the problem on it. That is, or do you have time? 5 minutes. Do you have time?
Sir, 5 minutes I can give. Sir, already 11 p.m. That is.
Okay, take
Your wish, sir, your wish. If you have time, I also have wish.
Yes. Because we have to, the chapter gets over, but the problem
Sir,
we have to do.
That, sir, you can tell me which number of problems I need to do, sir. Then I can do and let you know.
But how can you do? You don't understand properly this one. Na? I need to explain this question. Something I need to do now. See this one here. This line, page number 388. This one you can study. You keep on studying this thing. What are the racemic mixture? Like this one here, they are asking in this compound, identify the chiral and achiral. What is achiral?
Chiral and achiral is very easy, sir. Chiral means that it will not fit into its mirror image, and achiral means it will fit into its mirror image.
Achiral means no four different group, no four different group. And chiral means what? Four different group. Chiral means four different group. You see the definition. Four different group. Four different group. So if four different group are there, that is chiral. Now you see here this compound OH, Br, H, CH3. So this is going to be chiral. But here if you see, this is the chiral.
Achiral. Achiral.
And second one, two group are same, that is what? Achiral. Achiral. You can check the answer here. You see this is the chiral. Okay. Now the second one you see this portion. So this is the chiral. This is chiral. But
Second one
here
is achiral.
this second one is the same na ethyl group. This is achiral. Achiral. So you will find this one, see the chiral. And the last one here you see two hydrogen are there together. So achiral. And but here one hydrogen, one CH3, one ethyl.
Chiral.
So this is chiral. Okay. So like this we have to do the problem. So tomorrow we have to finish 100% this chapter. Okay.
Okay.
Okay. Bye.